everyone. Today we have our another new episode. This is our 554th episode. We will discuss on environmental engineering. We have our world famous speaker, Professor Ching, Professor David Smith, Professor Rob, and Mr. Marshall. First, I would like to give chance Professor David Smith to discuss about environmental engineering.
Well, Sharif, thank you so much. Honored to be part of the panel today. Environmental engineering seeks solutions to environmental challenges that impact the health and well-being of society and the environment. The, the technical skills that the environmental engineers use to develop strategy and technologies to protect and treat the quality of air, water, and the earth. It is a very broad discipline with environmental engineering, and that they have expertise in many of the different sciences and engineering disciplines to be able to do this. The environmental engineers really work with this broad knowledge and use technologies such as chemistry, biology, soil science, meteorology, and others to begin to pull together to ensure good air quality, controlling water pollution, and how do they remediate waste at contaminated sites and remediate the environmental and the waste in general. One of the newest areas in environmental engineering is actually they're developing means to protect the environment and ensure environmental sustainability. I'm familiar quite a bit with the environmental engineering programs at a couple of the universities around me here, University of Texas, Austin, and Texas A&M. And I can tell you the number of students in their programs are growing quite a bit. They're seeing a lot of particular opportunities as they graduate, from starting companies, looking at industry as environmental engineers, and particularly some of the larger companies, consulting firms, government agencies, public interest groups, and the ability for environmental engineering to have a major impact has never been at more of an inflection point. We know, as we've talked about on your program, Sharif, that the whole climate change arena, the environmental arena, is at a tipping point. And it's very important that this whole environmental engineering activity continue to grow and continue to have a place, not just within their own domain, but become parts of other companies that have a role in either worsening the greenhouse emissions, the pollution in others, and also those which are trying to remediate it. So it's a fascinating topic today, Sharif, and I look forward to hearing more from others.
Thank you, Professor. Professor Rob, what you want to add for this environmental engineering?
Sure, and good morning. Environmental engineering is the scientific approach to managing the environment. It's a degree you can pick up in a number of schools worldwide. The scale of environmental engineering has changed over the years. Increasingly, environmental engineers appear to be at least publicly focused on things like vertical farming, approaches to agriculture, for instance, that are contained and controllable. I saw one a few weeks back for the farming prototype. They didn't use pesticide. They actually used insects to handle many of the things that a pesticide or a herbicide might do. For instance, they would release aphids automatically if there was mold discovered on the plants, and then if the aphids got to a certain population or started to hurt the plants themselves, they would release ladybugs to eat the aphids, all without any chemicals or pollutants. And production per square acre was significantly higher than on an open farm, and used far less water, which is one of the big problems we have today. Agriculture uses a massive amount of water, and then it pollutes the water in its use by adding fertilizer, pesticides, herbicides, and other chemicals, other growth chemicals to the water and polluting it over time. So not only does it consume the water, the resulting runoff pollutes a lot of what it's not consuming. So it's pretty damaging. And so finding ways to avoid that pollution and lower the water use is a predominant way of trying to deal with some of the impacts of adverse impacts of climate change, at least not make them any worse. And certainly water shortage is been one of the major impacts. I'm attending Microsoft Build this week, and they've announced a major effort to quantify the world. Somewhat similar to NVIDIA's Earth 2 effort, but theirs, rather than trying to render the world, which is what Earth 2 is all about, and use that rendering as a large-scale simulation to address climate change, Microsoft is primarily focused on data capture. In other words, the very things that Earth 2 would need to remain accurate. So NVIDIA and Microsoft's efforts aren't competing, they're actually complementary. Though I've yet been able to determine if they're connected or not. That's one of the things I'm hoping to figure out before the end of the week. But in the end, environmental engineers, rather than complaining about the problem or throwing ideas at the problem without any concept of context or effectiveness, they work to understand the problems surrounding the world's ecosystem and come up with a scientific method to address them. And as I mentioned, in many cases, their efforts are localized, applying technology to increase farm yields without doing damage to the environment. In fact, as I mentioned, those methods actually are far safer than the more common methods associated with farming. But it is a critical career path given the impact we have with climate change, and clearly on the front lines of the people that are coming up with methods that may eventually allow us to dig out of this global problem that we've got.
Thank you, Mr. Marshall. Can you hear me, Mr. Marshall?
Yes, I can hear you. Can you hear me?
Yes.
Okay, so everybody that's talking about this is right on, spot on in terms of environmental engineering opportunities. I'm driving right now to my next appointment, but I just want to share with you that we actually have environmental engineers on our team. I had on a previous panel one of them who is a 28-year-old environmental engineer who essentially what she is she's both an environmental engineer and a biologist, and as in the UN for the Sustainable Development Goals. And these are the kind of people that we need to solve the climate crisis.
Hello.
As David and Rob have said, is they can you hear me? Can you hear me
now?
Hello.
Yes, you froze up for a bit.
So as I was saying, okay, so that's because I just arrived at a destination. So what's happening is what happens is that the environmental engineers, their role is to be able to execute the solutions that we have developed in lowering greenhouse gas emissions, improving soil health, cleaning up waste, and turning waste into a resource or a feedstock to produce other materials that can lower environmental impacts. So one of the things that we're doing is we create a material known as biochar, and biochar is one of the 6 carbon sequestration tools that has been recognized by the IPCC, and it's taking off like crazy. But in order to do this properly, one needs to have environmental engineers to execute what we're doing. And the environmental engineers are the people that not only build the ability to measure and track the environmental impacts, but they work together with our manufacturing engineers to build our systems and to increase and to ensure that what we're doing is trackable and also monetizable, so that we can monetize what we're doing for the joint ventures that we create throughout the world. And one of the things that we're looking to do is to create joint ventures in the developing world, such as in Malaysia and other places, so that we can bring these solutions to the table. It's the environmental engineers that bring the tool sets that our other engineers have developed and patented, such as pyrolysis, which is burning in the absence of oxygen at scale. We have the only system in the world that can handle both organic and inorganic waste, and turn that into material that can make money for the local economy, create jobs, and meet the 17 Sustainability Development Goals. My point about this is environmental engineers are a linchpin in the ability to solve the climate crisis and create climate restoration, climate repair. Without them, we would be at a heavy loss. The good news is, like in one of the panels, I had Hina Shah, who's not only an environmental engineer, she's a civil engineer at 28 years old. Remarkable young lady, very talented. And it's these kind of people that we need to bring more into the marketplace and create jobs in other parts. We can create, as I think Rob pointed out, there's schools around the world that give these degrees, but it's not just the degrees. One needs practical experience, and our team is bringing that practical experience in a new realm and a new method to be able to create solutions for the climate crisis. Thank you.
Thank you. Thank you. Mr. Adam.
Thank you, Sharif. Sorry, I'm a bit late. I think one of the most promising avenues that we can go down is to take inspiration from nature herself. We live in a time where arguably know more about, obviously there's still lots of mystery to cover, but we know more about nature than probably ever before. And we have the most advanced tools and technologies to study nature. We've got the microscope and the telescope, and we've got made more advancements in ways that we can study nature than ever before. So I think if we go down the biomimicry avenue, I think that could be a good way for humans to live more harmoniously with nature. I mean, already for several decades now, we've seen all these concept art and fantastical art of, vertical farms and, seasteads and colonies in what would have been ordinarily have been quite uninhabitable parts of the living world. So all these ideas have been around for quite a long time, yet we still seem to be a bit behind in putting these ideas, translating them into the real world. So hopefully, if we try and not lose sight of that, and investigate ways in how we can, use biomimicry more to our advantage, then I think that'd be a good way to go. Thanks. Sorry, my brain's not working properly today. I didn't sleep very well last night, so that's what I've got to think.
Okay, understand. Professor Ching,
Yeah.
I think you have many things to share.
Yeah, okay. Well, yesterday I wrote a letter to this professor, around Majandas. And his talk, actually just I can never match that, you see, in environmental areas. I would strongly recommend him, and I post this letter on the chat so you can read it. Also, before I did that, I wrote the letter to Federal chairman Jerome Powell. If he fails, then we're all in trouble. So I just, after I wrote the letter to the chairman, I say I might as well write a letter to someone I feel very experienced in environmental engineering. Okay, from his talk, I gather that he recommends what the Marshall said, that you need specialty to come into this field. In the old days, people just go major in environmental study. I met those people, they are not of a sufficient level to handle a problem that of such a difficulty. But now we have a situation somewhat different. So as Professor Majanda recommend, I will also recommend that students have a double majors, so they have a specialty to contribute. Okay, the major point I would like to make from a post-science point of view is that there should be two approaches to environmental studies. The first is the passive, which we're doing today. Everybody is trying to do this, do that, to fix this, fix that. Okay, the second approach is the active approach. Okay, the first one is the passive, the second is the active. From the point of view of self-creation, okay, I'm the person who already self-creation, the idea of self-creation. In other words, the exact definition is that the living system will self-create itself. Okay, the living system consists of not just humans, but also the entire environment that human can exist. Okay, so if you're looking at from the point of view of self-creation, you no longer try to solve crisis. Okay, you're looking at looking at how to construct, how to build a human being, or how to recreate the Earth's environment. Okay, this is totally contradictory to the current established view that human being come from random chance. Okay, I just cannot see this because after solving the problem complete automation, which identify DNA protein system as a complete automated software system, I cannot think that such a complex system is not based on design. Okay, there's specification, and even today nobody even understand that the DNA is a software. Okay, and the biologists today just refuse to let this idea of life science should be more like computer science than science. Okay, computer science is based on logic. Science is based on experimentation. It's just totally different field. And I'm the person who's starting this logic life science. And there's a long struggle ahead for post-science against the establishment. The active approach will find the range of temperature on Earth for human survival. Okay, people talk about global warming. Okay, what is the best temperature for people? That should be decided. Global warming is good. Global warming, good or bad? It's not, it's not a question. So, you see, there must be some good thing come from global warming. So we need to study from that kind of point of view, not just, every time there's crisis, we get some people try to handle the crisis. So these are two totally different beliefs and approaches. And I'm trying to start this new approach, which unfortunately is against the fundamental principle of science, which think science is the top knowledge people, and that they don't want anybody else from outside the earth to participate any of the knowledge. we have totally different view. We human beings did not create self on Earth, and we are going to create. Once we create a living system or create human beings, those things we create, what would they consider us? You know, all this idea, the logic is wrong. Okay, all this experiment, keep doing experiment, they lost this ability to reason in a very critical way. So I hope to contribute our solution of value to the School of Sustainability headed by Professor Aaron Majanda, because he's just crossed the bay in Stanford, and I go dance every Thursday, and I hope it's convenient for me to interact with him. I'm very fortunate that he's such an authoritative person. I hope our audience will also go check him out and listen to his talks. They are very, very comprehensive. Okay, they are all on YouTube, so this should be very easy. So basically, that's my view. I hope eventually Sharif will invite such a person to also talk to us, and I also wish or prepare something to challenge him, especially Adam and myself.
Okay.
Okay.
Thank you, Professor. Professor David Spitz. Yes.
What I enjoy about the topic today is it's a very old topic, really. And if you think about it, from thousands of years BC, humanity, we've always engineered the environment around us and what we have been trying to do with it. You can go back and look and see that in the ancient times, they controlled the water resources. They built wells, public baths, water storage tanks, citywide sewage collection systems, and they built early irrigation systems back in the period of beginning around 3000 BC. And so you begin to look at how it has changed. And, even the Romans built large aqueducts, which are really an environmental engineering type of approach to move water to help sustain life. And a lot of what is done in environmental engineering today is similar to what was done back there. But then you begin to see today that we've now done more than just move it. We're looking at how to improve it. We're looking at how to put water treatment, sewer treatment, to begin to update it. And those were done in order to help make us healthy and put the other places into it. You're beginning to see it used, as Rob mentioned earlier, in the agriculture area. We're seeing it used now in trying to deal with even environmental engineering extending to space and how we protect the ozone and how we do other elements like that. So it's a field that has been around for thousands and thousands of years, and one which continues to morph, continues to grow and change. To me, as a person looking heavily at systems of systems, environmental engineering is a discipline that lives within a system of systems world, that all of these work together, changes in one equate to other areas, and they have to take a systems of systems approach to begin to address the challenges in here. As we've seen in some of the public comments here, bioengineering, mechatronics are coming into play now as part of a environmental engineering approach. And the processes that are being deployed in environmental engineering are beginning to become more standardized, beginning to share more and more best practices globally. Environmental engineering for many years tended to be a local a regional approach. And with where we are today, environmental engineering has turned to a global approach because the problems are such that it takes a global solution. And the approaches to environmental engineering are ones that we're beginning to see grow in not just how do we deliver it, how do we improve it, but going to how do we remediate, and now how do we prevent. So that's one of the places where environmental engineering has changed over the millennium as we've gotten here, and it's expanding to how do we create a sustainable environmental engineering approach, and how do we take the sins of the past and how do we remediate it, and how do we create an environment that we can sustain for the long term. So that's a lot of the changes in environmental engineering. And a statistic I saw earlier was that the growth of environmental engineering programs within colleges has increased tenfold in the last decade, which is a good indication of its growing importance. So it's Sharif, you always pick great topics, and this is another example.
Thank you, sir. Thank you, sir. Professor Rob, what next? And if you share some historical background, maybe this is good for our audience.
Sure. Well, bioengineering goes back quite a ways. Between 2000 and 4000 BC, the Mesopotamian Empire, modern day Iraq, they created sewers. And sewers were seen as critical to the health and growth of cities. The getting human waste away from water sources and preventing those water sources from being contaminated was an early form of bioengineering, as were aqueducts. Of course, the Roman aqueducts are the ones that are famous, going back to 313 BC. The aqueducts moved water from places that had it to places that didn't have it, moved them overland pretty effectively, and the remnants of those aqueducts remain in place today. More recently, bioengineers have created biofiltration systems. These are systems that allow for the removal of harmful chemicals as water flows over land and into waterways, once again preserving the water's viability as a source for human and animal sustenance. Bioswales, that's similar but different in purpose. Bioswales are grassy areas that are created to do the same thing with rain runoff. When rain falls on streets and cities, it collects contaminants, and you have to remove those contaminants, otherwise they wash into your water sources and you have problems. And bioswales are these grassy areas, if you notice them around cities, that look pretty, but they're actually serve a purpose in keeping the groundwater from being more polluted. Surprisingly enough, environmental engineers have gotten involved with the creation of hybrid vehicles, which is the bridge step between gas-powered vehicles and electric cars. They're a way that a lot of us, we have a plug-in hybrid ourselves. I've got a full electric as well, but the plug-in electric hybrid allows you to use electricity when you're buzzing around town. But if you do have to go long distance where the electric ecosystem is in place, then you can use gasoline and do your occasional long trip. So it provides a much more viable alternative to either gas cars in terms of pollution or electric cars in terms of infrastructure while we're building out that infrastructure and making the switch. Environmental engineers have come up with certification programs over the years for building, LEED, BREEAM, Green Star, all programs that certify buildings to showcase that they are green and that you're not further contaminating the world as you're making buildings, but you're actually building ever more green, and the result is over time a reduction in harmful gases and pollutants. Eco-san systems, the ecological sanitation. If you don't produce a lot of waste and throw them into the water system, you won't have polluted water. It talks about treatment, localized treatment of sewage, and doing it very effectively. Also using composting and other natural ways to get rid of waste that benefits the environment as opposed to harms it. Ultraviolet germicidal irradiation. This is to use radiation, ultraviolet light, to get rid of contaminants in water at scale. Singapore is rather famous for doing this, but once again, a major focus on clean water and clean water at scale. Agroforestry. This is to keep trees and crops in co-residence. We've had a lot of problems and concerns with regard to the rainforest in Brazil being wiped out, a major ecological problem and disaster in the making out there. This approach allows the trees and agribusiness to co-reside, so you don't lose the trees, but you get the arable land for farming, and the two work in concert. A lot of environmental engineering is really looking at how can you use the tools the world has provided to do the things you want to do, as opposed to destroying those things and creating a new problem as you solve whatever problem you're trying to solve. And one of the most interesting things recently is high altitude wind energy kites. This is kind of fascinating to me, the idea of placing wind generators on a kite, large kites. Some of these things are huge. And flying that kite up where the wind is much more constant, allowing for the generation from wind to occur more 24/7. Where wind energy typically on the ground is only viable late afternoon to early evening. It's got the same problem over a different time span as solar, and that the plants will not run 24 hours a day, and you need energy 24 hours a day. The wind energy kites allow you to harvest energy 24 hours a day. Granted, they do provide a bit of a hazard for aircraft, but these can be marked and aircraft can guide it around them. In effect, we have air highways that aircraft fly over anyway. It's not like they fly every place willy-nilly, but that would be the concern, of course. Much less likely to harm birds because they're fairly high up in the air, and as I mentioned, they run 24/7, so very efficient. And other than that minor problem with regard to air traffic, which is avoidable, they've proven very effective. And so environmental engineers have been having an impact even before we called them environmental engineers, going back thousands of years to sewers, to aqueducts, and now high altitude, wind energy from kites, which I still think is one of the coolest things that I've seen of late. So those are some of the examples, historical, that bioengineers have had some involvement with. Excuse me, environmental engineering.
Thank you, sir. Mr. Marshall.
Yeah, I think this is a great topic. As everybody says, I'm finally in my office, so apologize for the travel. But basically, the environmental engineering discipline, as both Rob and David have pointed out, and everybody else on this panel, is an interdisciplinary approach to dealing with our environment. And as everybody points out, it goes back millennia, essentially. I mean, from the Roman aqueducts is environmental engineering to handle water. But in today's deal, and I think in today's situation with the climate crisis, and I like what Hugh said, that it's got to go beyond crisis to discipline that actually provides future opportunities for humanity to grow and to stay healthy and to prosper. In that regard, in a practical sense, and that's where I'm coming from. I'm not a professor, I'm not a doctor, but I have on my team a whole slew of environmental engineers that are interdisciplinary. As I pointed out, Hina Shah, who had been on a previous panel here, has a degree in civil engineering together with environmental engineering, and that crosshatch of allows us to be able to have somebody on our team that can go and look at how and ensure that the actual practical applications take place. And the reason that is able to be done is because even though she's young, she's very brilliant, and she has a lot of experience, believe it or not, and able to give practical applications their implementation capability. And so one of the things that we're doing right now, and I'm going to give examples of environmental engineering. Examples of environmental engineering are as follows. We have the ability to take what is known as pyrolytic carbon capture and storage systems that are scaled. We're the only ones in the world that can handle 120 metric tons a day from one unit, and convert that into, take waste, which is normally toxic or causing harm to the environment, take that waste and convert it into a material that we call elemental char. It's biochar if the source of the feedstock is waste, such as sewage sludge or crop residues or forest residues that cause forest fires. We could take all that material and convert it into a material known as biochar. If it's known as PREF, which is pre-engineered material, which is usually textiles and plastics we all know come from the fossil fuels industry, we can actually take that material and we can convert that. Many people today are trying to convert that material into energy because fossil fuels are used for energy. But it creates more problems than it's worth right now from our perspective, because it creates more pollution. And there's a lot of greenwashing out there that causes these issues to be misconstrued. So one of the things that I like about what he was talking about, and everybody on this panel, is we need to educate people about the true elements that are going in to how to solve these climate crises and go beyond it, as Hugh says. So I think one of the things that we need to take away from here is that what we're doing is we're taking various tools and we're creating several opportunities in one fell swoop. How do we do that? We create joint ventures with people who have the waste, who have the permits to handle the waste, who have the landfills, who move the waste, or have so much waste that they're burning it or burying it. And so what we have right now is 9 joint ventures. Those joint ventures get funded through a climate bond under a specific taxonomy. That taxonomy, as I've said before, what's a taxonomy? It's a set of rules. And those taxonomies are very stringent, and they protect us against greenwashing. Greenwashing is where people say one thing and do another. And the typical greenwashing is many fossil fuel companies out there went out and got climate bonds, or not climate bonds, but green bonds. They're not climate bonds. And they use those bonds to fund opportunities for more fossil fuel development, which is really not the future of this planet. So the fossil fuels still have a role. They're going to be a role that's going to continue over time. But as we move not just towards solar power and nuclear power and reinstitution of nuclear power and other wind power, we're going to see the use of waste as not only a source for power, but actually a source for material that can clean up the waste that we have that is built up over, since, decades. And we can clean that up, turn that into a feedstock that actually recreates jobs, lowers poverty, increases health, and at the same time solves the problem that is delineated in the 17 Sustainability Development Goals by the United Nations. And we're big proponents that we need to form more joint ventures, because it's through joint ventures that we create value for and good employment for people, especially in the developing world. That's where we need to do it. It'll be done through private-public partnerships. It'll be done through private partnerships. But the point is, it needs to be done, and it needs to be done soon, because unfortunately, whether we like it or not, whether we agree with it or not, the climate clock is ticking down. Once we get beyond the climate clock and we push the hands of time backwards, which is an old rock and roll song, by the way, what we can do is we can then reach out and begin to restructure our society, as Hugh has pointed out, in a way where we can use different tools. And I always become more of a proponent for Hugh's concept of fuzzy logic, because fuzzy logic is not just the logic that we talked about yesterday on the panel. It's the logic that says it's the logic of human beings. Human beings are fuzzy logic, meaning that what are we doing? We don't, it's not yes or no. It's not zeros and ones. It's something that is a value system that is not quite 100%. And we're never going to be 100%. Nobody's perfect. No human being is perfect, but we need to make the effort. And that's why I applaud Hugh, David, Rob, and Adam, and that Sharif through the World Talent Economy Forum is actually propagating this opportunity for all of us to band together. We need all hands on deck. Time is of the essence, and environmental engineering plays a pivotal role. It's a linchpin to be able to implement what we need to do now. And as Hugh pointed out, it's not the old school. We need proactive abilities, and our environmental engineers are getting that in place right now as we speak in the 9 joint ventures that we've formed so far. And what we're doing is we're taking waste, we're converting it through pyrolytic carbon capture and storage, using that material as a filtration media to clean up water, along with our ultra nano bubble generator. We can also do other things with it. We have a Zajac engine, which takes out greenhouse gas emissions and cleans it up at scale. So there's a lot that can be done, and provide power in places where there is no power. So to give you an example, 40% of India is off the grid. There's no grid. Those people spend most of their time having their children and their wives walking around gathering wood, which is getting scarce, and trying to create power and energy from that fire. We need to, that's like going back to caveman times. They've been that way for a long time. We need to change that, and it needs to be changed now. And we can bring that to the local population so that they're independent of the grid, create their own power, create opportunities to improve their soil health through biochar, and at the same time improve and reduce zoonotic diseases such as mad cow disease, which is or other diseases that are in all sites of livestock, which can be handled through a biochar that is formulated and fed through veterinarians to livestock. It reduces the mortality rate of livestock by a minimum, not a maximum, a minimum of 50%. We have double-blind studies on this done in Europe, and we know that it's true. The key here is that what is preventing this from happening is greed. That's my opinion. It's not a political statement, it's just a fact. People want more money than what they care about the environment and the health of people. We've seen that all over the world. We need to support the World Talent Economy Forum out there. Everyone that's watching this program needs to jump in, contact Sharif, find out what role they can play. And if they need education, the World Talent Economy Forum is providing that educational program. I know we've done programs in Rwanda. We're doing programs in India. We support all that. We need education. We need development, but what we need environmental engineers. If you're interested in becoming an environmental engineer, this is a new opportunity. It's not the environmental engineer of our grandfathers or our great-grandfathers or people who built the Roman aqueducts. This is a totally new world. It's a new world with a new application, very interdisciplinary, and that can be seen through, if you research and you look at the 17 Sustainability Development Goals of the UN, you'll see what environmental engineers are all about. That's what needs to be done. And Sharif, I praise you and everybody on this panel to get this done. Thank you.
Thank you, sir. Mr. Adam.
Thank you, Sharif. So as well as biomimicry, like what I mentioned earlier, the kinds of technologies that we see emerging in the future and near future could be advanced enough and versatile enough to repair the damage and heal the wounds that more invasive, bulkier, macro scale and fossil fuel based inventions and infrastructures left behind. Perhaps even civilization itself cannot grow without growing pains. Maybe we as humans, human society had to go through its, maybe not, but maybe human society had to go through its unsustainable, polluting and dangerous and harmful technological age in order to reach this more ecotopic, sustainable, greener, healthier and happier new age, this coming age of wellness on both the individual and societal orders, going from the browns and greys of concrete, steel and smoke over to the blues, greens and yellows of healthier oceans, grasses and solar wellness. Some people might disagree though, where arguably we could have skidded around the satanic mills of Victorian industrial revolutions and gone straight to the utopic and techno-optimistic age of solar panels and vertical farms and medicines without such dramatic side effects. So it's the deus ex machina quaternary of nano, bio, info, cogno, the applications of which are staggeringly broad and applicable to probably every human endeavor and priority. So using that technology to clean up the mess that previous tech caused on the way to get to such an advanced stage in civilizational technological flourishing, which seems a bit circular until you realize that there are so many more applications for such inventions that previous generations of technology could never do. So it is important that in education, the practical side of these applications are not neglected, where we can inspire new generations of young people to have enough confidence to know what to do with their hands, get their hands dirty with soil and water and grass, to feel like they belong to the land and that they belong to this beautiful natural life cycle. One of the problems I find with this kind of Neil deGrasse Tyson, Bill Nye brand of pop science is that it makes viewers and readers and listeners feel small, especially in reference to something like astronomy or astrophysics, where you hear such tropes like we are, insignificant specks of dust in a very big universe, where our lives are like blinks of an eye. So we want young people to feel the opposite of that, where they feel that they can make an important contribution, where they matter and their lives matter, and what they do in their lives has an impact, and it can be a very positive one, not an insignificant one, which ties into a problem with a lot of ingenuity in that we have the technical feasibility to achieve what we are, kinds of things that we are discussing today, but many of the roadblocks are societal and cultural, which Mr. Marshall also touched upon a few minutes ago, and he was also right that he was also correct about the interdisciplinary nature of these endeavors. So, yeah, thank you.
Thank you, Professor Ching.
Yeah, well, after listening to Marshall, I feel I should write another letter to this professor regarding fuzzy logic. You see, reality is fuzzy because precision is sacrificed in the process of expanding the range of tolerance, where the range of tolerance is what we should be dealing with in environmental issues. Okay, what is the range that we tolerate in the atmosphere? Okay, ozone layer, the ocean. Okay, how much pollution can we stand? Okay, it's really in the old days. Talk about history. Rob talk about history in the old days, very old days. Dinosaurs like carbon monoxide. And the human like oxygen, and oxygen is very poisonous. So all these questions are really, very, it's not as simple as we think. Okay, basically, I feel actually the environmental engineering field is putting all together under one roof, which give our valuation system a chance to participate in this field. And the valuation system is called infinite spreadsheet, so it include every factor. It does not allow things, and having the solution value allows Postscience to speak on almost any subject. On the other hand, we cannot speak on subject if we have not had a chance to value its worth. This is true in the current case. So I'm very glad that I have learned a great deal from our fellow speakers on the subject. You see.
Thank you, sir.
Yeah. Okay.
Yes. Yeah. No, you can continue. In between
Whatever
2 minutes, I will go for concluding remarks. But
okay.
Next 2 minutes, you can.
Sharif, thank you again. Great topic. I think it's important, though, us to emphasize that mankind humankind decided this was important millenniums ago, as you began to look back at how it was used in the ancient civilizations. And as both Rob and I said, this began back over 3,000 years BC, and it's continuing in today. And it's picked up steam, it's picked up specialization, and it's changed its focus from just delivering to preventing and solving the problem. A lot more effort is needed. Great opportunity wherever you are in the world, because these skills are going to be needed globally. So great opportunity for education, great opportunity for entrepreneurship, and it's one that is needed for our time. So thank you very much.
Thank you, sir. Thank you, sir. Professor Rob, I know you are in hurry. What is your concluding remarks for today's session?
Yeah, I've got 5 minutes. Environmental engineers are an amazing group of folks. The kinds of things they're working on today range from green hydrogen, which we covered in another program, advancements in solar energy production, both terrestrial and outer space. Some of the stuff is pretty amazing. Ocean thermal energy conversion, which is kind of fascinating, because the ocean collects enough energy to equal 250 billion barrels of oil a day, and you can use the temperature difference between the surface and the subsurface to generate a lot of power and remove heat from the ocean in the process. Creating oil from almost any kind of carbon-based waste. And that might sound counterintuitive, because it's certainly not keeping the pollutants out of the air, but it's neutral in the pollutants in the air, but it's removing pollutants that would otherwise go in landfills. And so instead of pumping oil out of the ground, why not convert waste that's currently going to landfills to oil and use that instead? At least it eliminates the stuff that's going into landfills. Wave power, a very clean source of energy and almost continuous, has made great advancements over the last few years, with large trials moving into production areas. California, I believe, is looking at that pretty heavily at the moment. Planting on roofs of buildings. When skyscrapers and buildings go up, they destroy plant life, and of course we need plant life to help regulate our temperature and remove the pollutants from the air, especially CO2. Putting large gardens on roofs of these buildings allows you to preserve the plant life while still building up the buildings, and that overall work to use the natural aspects of the planet to clean up the mess is a major part of what these environmental engineers do. The CO2 sequestration, taking the CO2 instead of putting it up in the air, pump it down to the ground into empty mines, embed it into rock, create solid forms of CO2 and bury it. It's still probably better to stop producing the CO2 to begin with, but at least this keeps it out of the air. And so these methods are being advanced. They're pretty expensive at the moment. And then, of course, the thing that I've been looking for decades, but still hasn't happened, is making paper obsolete, going to a different technology that is far more reusable. I do remember the science fiction series that I was enthralled with. It was at least the first 3 seasons, Babylon 5, when they used to get the newspaper out of the machine, they'd read the newspaper, and they'd put the newspaper back in the machine where it was fully recycled and delivered to the next customer. We can do that scientifically. We just can't do it cost effectively yet. But those are all kind of projects that environmental engineers are involved with today. It's an amazing area of study and research, and goes to the heart of what we need to do with regard to preventing or protecting against and mitigating climate change and other forms of pollution that fall into the area of things we should be doing anyway. Environmental engineers are at the forefront of that, and a critical career choice, and one that appears to be growing at the moment. So good luck if you decide to choose that particular path.
Thank you, sir. Thank you, sir. Dr. Talib Rafal, we are discussing about environmental engineering. What you want to add for today's discussion?
Thank you. I'd rather listen. I just joined you, so I'd rather listen a little bit and then I'll speak.
Okay,
Thank you so much.
Thank you, sir. Thank you, sir. Mr. Marshall.
Yes, Sharif. So I think the panel today has delineated environmental engineering. It's a multidisciplinary approach. These are my concluding thoughts on it. I think that in addition to the fact that it's a multidisciplinary approach, and as Hugh has pointed out, it needs to become more proactive, and that's what our team is doing. Our environmental engineers are actually proactive. We are implementing new solutions. The solution that Rob referred to, which is CDR, carbon dioxide removal, is gaining a tremendous amount of press, but it has a long way to go. The good news is there's a much easier way and a lower cost way to approach carbon dioxide removal rather than just taking it out through chemical processing and burying it into the ground. Actually, what we need to do is what our team is currently doing in its 9 joint ventures is to take the materials that cause, which is waste, and take the carbon out of that waste and convert it into products that actually reduce more environmental degradation that prevent that. So that's what we're doing. What we're doing is we have the tools to take carbon out of the atmosphere, create energy out of it, but also create products such as a carbon sequestered concrete or cement or macadam for building purposes at an infrastructure level. And that's what's required. The second thing is you can take carbon waste and you can convert it into a material known as biochar if it's properly manufactured and formulated. And that biochar can actually improve soil health, reduce crop devastation from pests, and at the same time improve the productivity of crops. We're about to embark, and we're going to see it in the next few months, and I'm sure we'll be talking about this on the World Talent Economy Forum, about the food crisis that is going to hit us like a tsunami. It's coming, and it's going to be here soon. And what's going to happen is once that occurs, everybody on the planet is going to be affected. It was occurring already, but it's just been escalated by the war between Russia and the Ukraine. And because the Ukraine has been a huge grain producer and it's not producing grain, countries such as in southern Africa and sub-Saharan Africa and other places of the world are going to be affected by it. And so we're taking steps to move that away from that, in other words, to improve food security, but at the same time, using these tools that environmental engineers work with to create the opportunity to improve soil health, crop opportunity, livestock health, and at the same time, better food security for underprivileged populations that we see in the developing world. And in the developing world, by the way, there are places in the United States where there's poverty. So it's around the world. It's something that needs to be attacked at a high level, at an infrastructure level, which leads me to my final comment. The World Talent Economy Forum is placed in a great opportunity to affect public policy with such people that we have on this panel today. And I reach out to all our fellow panelists and all the people out there watching that we need to encourage the World Talent Economy Forum, join forces with us to create public policy that will accelerate the opportunity and get rid of the greed and overcome the greed, and people will make money. We'll create a great middle class around the world, everywhere it needs to be done. There's an upcoming COP meeting in Egypt, COP 27. I think it's in Sharm el Sheikh. And if you can join there, join. I hope they're going to do it virtually, if not physically. I know that they're going to do it physically, but hope everybody will be able to participate, because we need the world to come together and not fight each other. We need peace and we need opportunity. But people are suffering in poverty. They're suffering in many ways. But one of the things that they're going to get suffering for the greatest is not political. It's going to be climate. Climate is here. It's affecting us. We see it in India. Right now, the ground temperature in parts of India is 62 degrees centigrade. That's untenable for farming, let alone human existence. And that's happening. It's not on a consistent basis, but it's happening. And we're seeing it, and that's coming from climate change. And that climate change is weather patterns It's also not just climate change, it's not just weather patterns, it's also climate change over time, and it's accumulating. And we need to take action now. So we need all hands on deck. We need people of all good conscience, all good intention to work together across political divides, and we need to get this done as soon as possible. So, Sharif, thank you for everything that you're doing, and please continue the good work. Thanks.
Thank you, sir. Thank you, sir. Mr. Adam.
Thank you very much. I liked what Rob said about ancient Mesopotamia as well, because, like I said a few times before in other episodes, it's worthwhile to look back, employ scientific historians to study innovations from civilizations past. This is absolutely worthwhile. I'm a great believer in posterity and keeping the memory of people and civilizations alive, no longer how many millennia they have been dead for. In fact, this is partly why I'm a transhumanist. I found Ray Kurzweil's ambition to live forever and even resurrect his father from photographs and documents and sheet music he composed. Very inspiring, if a little too ahead of our time. So we must not be too quick to dismiss the findings and discoveries and innovations of past civilizations. The bias that the more ancient world is something, the more ancient something is, the more primitive and stupid it is not only unhelpful, it's false as well. It's not a linear trajectory going up neatly like this. It's cycles within cycles within cycles, and many forces colliding and missing and recolliding. So yes, keep excavating and preserving what we find in cradles of civilizations like modern-day Iraq. And we may be pleasantly surprised to discover civilizations hundreds and thousands of years ago that got close to our level of technological development. Who knows? One never knows. Like Marshall said, the interdisciplinary necessity of all this cannot be overstated. That includes collaborating with those who came before us, because who knows, maybe ancient Mesopotamia left something behind which could be crucial to saving our own civilization. I know it sounds quite wild and fantastical, but those are my feelings, and I also agree with Mr. Marshall about crossing the political divides. We talk a lot about people coming together, and maybe it's time that, as difficult as it is, people from opposite ends of the political spectrum can come together and work together as well at last. So those are my final thoughts. Thank you.
Mm-hmm. Thank you. Professor Ching.
Yeah, okay, well, Marshall can be my teacher. Okay. And our Postscience contribution to this, environmental issue is, we're contributing the idea of permanent sustainability. Okay, and that was one of my shortest talks, in public. I say I only had one word to contribute to the field, that is permanence. Okay, so that is basically what, and also Marshall mentioned this food crisis. Okay, this remind me to probably to write another letter to Jerome Powell. Emphasize increasing interest rate is not the way to solve cost push inflation. Okay, the way to solve inflation is to have valuation, solution value, okay, which will put the price at the right level so it will not crash. For example, in the savings and loan crisis, we use interest rate, and it caused the savings and loan crisis. All the savings and loan association, banks all went bankrupt. It was a complete wipeout of the savings and loans. So, I need to write another letter I need to write 2 more letters to these people in charge, emphasize, we should use valuation, not raising interest rate to solve the problem of inflation, cost push inflation. Okay, so, I will leave more time to Professor Talib to offer his views.
Thank you, sir. Professor Dr. Talib. Yes.
Thank you so much, Dr. Shank. I don't know if I have much to add here, but what Marshall said and what Adam said is very correct. I think the problems of today have no borders. Governments must work together. There are no borders to climate change, no political borders. Therefore, we must work together as governments. Let's work together as people. That's for sure. Now, regarding the previous civilizations that Adam referred to, I'm 100% for it. I think the previous civilizations are very, very important to us. Yes, today's life, today's culture. Today's life is tomorrow's culture. So, we must be very respectful of what they have to offer. I 100% agree with you. I just wanted to add these two thoughts. One on borders, the other one on civilizations. Thank you so much.
Thank you, Professor.
For all the work that you're doing.
Thank you, Professor. Thank you, Professor. We just want to share some good news from World Talent Economy Forum because our open dialogue becomes so popular in the intellectual communities. I already shared that energy ministries, ICT ministries from developing nations, some countries' prime minister office, they are collaborating with World Talent Economy Forum. They want this kind of open dialogue from developing world. Yes, developed nation has a lot of knowledge and resources, but we can develop ourselves. So what is the way from my visions, how we can inspire the youth community, inspire the grassroots level people? We need to more focus on research and innovations. We only cannot dependent on other countries or dependent on the big things or everywhere. We have to develop our own ecosystem with modern science, engineering, and technology. That's why we are taking initiative next year, March, 27 March to 29 March in India. We are launching world largest conference on Nikola Tesla technology. You know, Tesla actually invent a lot of technology, and from our lab, we are in uplifting the technology. And millions of people, it's not only conference, we are engaging with grassroots level people. They will get benefit from this kind of benefits. Beside that, with Singapore, we are working to developing the futuristic leaderships. In Malaysia, we are developing Industry 4.0 related hard training courses like hard skill development. India, Bangladesh, Pakistan, we are working. We want to visit Dr. Talib village. I want to go to your village where you born, and I want to meet with your people, and we want to work together for innovations.
Most welcome.
And yes, and anyone, those who want to invite us, Adam, you can invite us in Europe. Professor Ching, we can visit Silicon Valley. Mr. Marshall, we can visit your plant. So this is the way we can create both. Like when, for my learning purpose, I go to Harvard, I go to Oxford, I go to Cambridge. The same thing, developed nation also can come to developing world. They can go to Dr. Talib Raphael village and can learn new things. They have new innovation. Maybe they have social entrepreneurship. Maybe they have new research field. We can work together. This is the way we can minimize the gap. And this is actually our objective, and how World Talent Economy Forum actually collaborating and getting support from developing nations. I really, really want to give them thanks. I request all of our audience, please share our content as much as possible with government, with corporation, and for academia. And I am from a small country, and I am for grassroots level people. And I want to give the big thanks to all of our great speakers like Dr. Talib Raphael, Mr. Adam, Mr. Marshall, Professor Ching, Mr. Adam, Mr. Rob, those who continuously support our initiative. We are very small, very small. We do not go for any commercializations. We do not get any sponsorship or any support. Only your good contributions help us a lot. Thank you for your excellent contribution.
You're doing a very good job.
I request all of our speakers, please join our new innovations, join our different initiative. I can ensure this Nikola Tesla technology, we invite 25,000 scientists around the world, and we are getting huge support from them. So hopefully,
Where in India? Where in India?
It will be in Kolkata. It will be near
Kolkata.
Kolkata, the palace. And we actually get a palace from them. So we'll organize it in a palace.
Very good.
Yes. So I will invite you all, and we are publishing a lot of paper, especially the young people. I'm very, very happy. Professor Talib, you can write paper on talent economy. We are publishing book. Professor Ching, you can. Adam also writing paper with us. And most importantly, Mr. Marshall, how you write books and everything. I'm really inspired, and I request all of our young people, you have to write some high quality paper. It will help for your career and help for your country. Thank you. Bye bye and take care.
Bye bye.
Thank you.
Thank you.
Thank
Thank
you,
you.
Sharif.
Thank you, sir. Thank you, sir.
Thank you. Thank you.